Assalamu alaikum wa rahmatullahi wa barakatuhu. Welcome to Haseeb Electronics. Friends, in this video we will practically troubleshoot and test ATX power supply. I will share some basic tips, basic requirements for testing SMPS switch mode power supply, ATX, this for computer. So let's start. Before starting power supply, I have to share some basic and very important informations for power supply. We must know the colors. It's very important. Block sketch, then we will go in detail. We have input and filter. We have rectifier section. After rectifier we take two type of powers, 330 volt DC here. The first, it is standby power. In first stage we will take standby power, this power supply, and we have secondary or main power, main or secondary power. This standby power will initialize the motherboard of the CPU, and it will also power up and bias the components of this power supply, this power section. So this we say SB, standby voltage. After that, this voltage will go to this VCC. It is a VCC for these components, and here we have inverter. It will drive this inverter, and we will take output, and there is a control or feedback or over voltage protection, and it will control this. This is our total circuit. We take 220 volt AC, then it will rectify here. We will take 330, and this is applied to inverter, and we take this voltage, and this voltage will apply to standby power. Standby power will give voltage to motherboard and also give power to main or secondary power supply. Then after inverter we will take output, and output will be rectified and regulated. Then it will be controlled and feedback to the control portion, PWM control portion. Let's start our subject. In the first stage, when we apply power, we get voltage on this SB power, standby power. We take 5 volts standby, it is about 1.8 ampere, and the same voltage are applied through this resistor to the motherboard. It is called PS on signal, the green wire. Purple wire, in first stage, from here we apply AC voltage. After AC we have here filter circuit, rectifier section. The inside there are diodes, okay, and here we have Inside we have diodes, 4 diodes. We will see step by step in detail. From here we apply input, filter circuit, bridge rectifier. I have discussed this diagram in very detail. I will give the link in description. You can check this description over there. We have DC 330 volt here, and it is applied to this inverter section. Here is one transistor and some other components. They make oscillation. We take 5 volt purple wire. This voltage we take purple, and the same voltage through this resistor are applied to green wire, and this is controlled. This is applied to control signal. Okay, this voltage PS on signal. Normally the SB voltage are present in this wire, but to power on we have to connect this wire to ground, or when we press in the power on button, this wire will be connected to ground by the CPU motherboard. Then we have PG signal. We will discuss it at the end. Then we have set of orange wires. It is 3.3 volt up to 7 ampere for processor and motherboard and ICs. Then we have 5 volt 12 ampere. These are secondary powers. This is basic main power, this standby power, and this is our secondary power. First stage we must have this voltage. If this voltage not available, this power supply will not work. When this 5 volt available, CPU motherboard will initialize, and it will accept the power on command, and it will connect this pin to ground. Then this section will start. This PWM will start. Actually, this voltage control the remote on command of this IC. Processor voltage 5 volt VCC for all system. Then we have plus 12 volt 9 ampere yellow wires. Then we have black wires. This is a return or ground. Then we have minus 12 volt 0.5 ampere. Let's start. So for repairing any ATX power supply, any power supply, because it is a power section, you have to take some special cares. What are that? First of all, to test any power circuit, you need a series lamp. If you have a holder, you have take one line directly. This is my incoming line. The voltage are coming from this side. Okay, I connected one line directly to this power cable. Okay, and one line from the main line I connected to this 75 watt tungsten lamp, not LED, not anything, this 75 watt lamp I connected to one end, and from outer body I took the signal voltage from the outer body, so I insulated it. If you have holder, you have two connections and the holder. Connect one line coming from the main line and connect the second line going to the power supply. So this lamp will come in series. How we will connect? This our 220. Take this voltage directly to power supply and connect here. This to power supply. This 75 watt, 75 to 100 watt. Because our power supply is 150 watt, 200 watt, 300 watt, 250 watt at full load. So in any case, this is very good safety. In any case, if we have any short circuit, any component short, initially or while working we make a mistake, because when you are working we can mistake something. So if we make mistake, this power supply will get more damage. And if you use series lamp, the total load will shift it to this lamp and this circuit will be protected. For example, I have this serviceable power supply, it's good. I will connect, see the lamp, I will connect the power, just see the lamp. In the first stage it will take a slight light, the capacitor is charged. Now this supply is ready to work. When you want to test power supply in first stage, before doing anything, take multimeter, connect black lead to any one black lead to any one pin. These are colors, this is return line. I will connect black lead here, black lead here. Now set to DC. As I told, we have to check voltage from the purple wire. In some power supplies it is here at number 4, in some number 2. Anywhere you have to locate the purple wire. This wire you have to check, and we have to check the voltage at the purple is 1, 2, 3 and 4. 1, 2, 3 and 4. We got this voltage at purple wire. At this wire, at purple wire we got 5 volt. This voltage must present. If this voltage are not present, we have to troubleshoot the other powers. If we don't have this voltage, we have to check this section, and before that we have to check the input section and rectifier section. And if this voltage are available, then we will check the green wire, then we will check the power on signal, that is green wire. I noted here green wire, so we have to check the green wire, this green wire. So this voltage available. Okay, then you have to check. Now this time we are taking just only primary voltage, standby voltage, and we have to check the orange wire, no voltage. Any other power supply should not have any voltage, just only the purple. Here is green and purple, just only 2 wires must have voltage. It is a basic test. If any power supply is giving voltage to other supplies, other wires, that means this power supply will be bad. So this supply is working in good condition. So now to turn on power supply, I will connect it here at yellow. And now to turn on power supply, come to these lines. We have to connect this green line to any one line. We can see I get voltage. When I will remove this pin, no voltage. I will connect to ground, black and green. you have to make a jumper between black and green. When we will make jumper between black and green, the power supply should power on. In the first step, I told you, you have to check the voltage. If any power supply, any PSU, any ATX is giving voltage in this condition without jumper, that means the power supply is bad. Now, if we connect jumper here, if I have 5 volt at green pin, if I have 5 volt at green pin and I cannot find the output voltage, when I make jumper, I cannot find output voltage, 5 volt, 12 volt, minus 5, minus 12 volt, other supplies 3.3 volt, that means you have to repair the power supply. In all conditions, sometime we connect a jumper, it is a very common fault. We connect jumper and the multimeter will show for a while like this, and then it will go to 0. Power supply will start to turn on and then it will go back to 0 like this. 3 and 4. It will turn on and then it will go to off. The fan will start and then it will go to off. We will discuss in detail why this happens. So first we have to use a lamp, series lamp. It is a very basic and very useful. So let's start our subject now. The same condition, I will connect multimeter to any one black pin. We can connect to any jumper, this jumper, this jumper. So this jumper is easy. I have 2 black wires. Connect any black wire here. Now, before working, I will give some image. We have 2 sections, hot side, cold side. Which one is hot side? Main power, primary section, that is our primary section, hot side. We apply 220 volt. It goes to fuse, NTC, filter capacitor. Then there is a rectifier inside here, bridge rectifier, and then we take this voltage at the capacitor. After capacitor, we will take inverted voltage from chopper at this purple wire. Let's start. So when you are working in this area, you have to use the ground from this capacitor. From this capacitor, negative side. This is ground hour. And when we are working in cold side, we have to use black wire. Here we will use the capacitor for ground signal to set our test instruments to ground. We can see I connected this pin to ground, and we will check. When we connect series lamp, if our lamp gives light like this, that means the power supply have no short circuit. If we have short circuit in any component, at thyristor, at voltage arrestor, MOV, capacitor, anything, bridge circuit is short, that time we have problem in the input and filter area. This time this lamp just glow for a while, after that it is off, that means the power is stable. As I discussed, we have to check voltage, DC voltage at purple wire. I have 5 volt. Then I have to check voltage, power on voltage. It must be pulled on. It is 4.0 9 volt, because it is through pull-up resistor or series resistor voltage divider network. Now I will connect to any one power supply. I will test all power supplies. No power is available. Now we will apply a remote on command. This green wire, this green to any one black, this black or this black. So now we will connect. I connected the 5 volt available, 12 volt. So this is our main switch. This is our circuit breaker to turn on the other power supplies. Okay, now we have some questions. The first question, that is, if I have this 5 volt, that's okay. If I don't find this 5 voltage, this 5 volt, what we will do? We have some conditions now. The first condition, we have to check input voltage. If we don't find the standby power, this is our first condition, that our lamp, series lamp, does not give any indication and we cannot find anything. We have to check the AC voltage, set multimeter to AC and connect at input terminal. I have 233 volts. So maybe in any condition I make testing and I make jumper. I make, while touching the lead, if I made mistake and this jumper, this pin connected to this wire, the nearest track, what will happen? If I did not connected the series lamp, maybe another damage will occur. But now our all load will be transferred to series lamp, so we are safe now. So here this voltage, and after this line we have here NTC, this black component NTC, and then we have here fuse. After fuse, after this disconnection, from here to here I have fuse. We can see here this voltage 233, and from here to here I have this voltage, and after NTC we have to check here. If NTC is good, we will find voltage here. Okay, after that we have this dual line filter. From this disconnection we have one line here and one line here. It is our input of the inductor. After inductor we find voltage here at this point, at this point. So if we find this voltage here in these 2 points, that means this section fuse, NTC, inductor is good. Then we have a yellow capacitor for filtration, for EMI filter, for high frequency removal. So we will find voltage at this point. And if I see this diagram, fuse, NTC, filter, inductor coil. After inductor coil we have this yellow capacitor, and we find this voltage on the 2 ends of the bridge rectifier. So if I come very closer here, let's see the circuit, and then we will continue. If we see this line is connected to 2 points here. and this line is connected to 2 points here, this line and this line. This point is this bridge, these 2 points and these 2 points. These 2 points are bridge rectifier. If we find AC voltage at bridge, that means our rear circuit is very good. After bridge rectifier, we have DC voltage. Set multimeter to DC, set multimeter to DC, and we have the same here, 2 diodes and 2 diodes. If we see this one and this two, okay, this one and this two, so we have 2 lines. So here we have a 2 capacitor in series, 1, 2. We have 2 capacitor, main capacitor in series. So here are voltage divided, because this is half bridge technology to get more current. So we will take DC voltage at 2 capacitors, 330 volt, 327, and if we check voltage at individual capacitor, 163, 163, because 2 capacitors are in series. So we will check the voltage in the ends, one capacitor negative and the second capacitor positive. So here we have this voltage 330 volt, 327, 330 volt. If we see this power supply, it has some important sections. What are that? Filter and protection circuit, rectifier and DC bus bar. This is called DC bus bar. Rectifier and capacitors. After that we have standby power. Standby power, this transformer, here is transistor, and 5 or 6 components here. If we come here, the same voltage from the capacitors, 2 capacitors, come to this circuit. This diagram not for this power supply, but all ATX power supplies are approximately same. There is no difference, just only the type of components, sometimes different, size and design different, but the technology is same, no difference. So here we are using one transistor, some components, diodes, and we are taking output. In other power supply maybe there is some IC. If you will see this circuit, from this capacitor we take voltage from here to this IC. Here we have TNY277, and then we have this transformer here, T2. The basic phenomena is to switch voltage and send it to output for biasing power, standby power. So we have to monitor the voltage here. We have to check these components if it is not working, and then if it is not working we have to check the optocoupler. If we are getting in the input section some voltage, so 1 volt, this optocoupler, that means this optocoupler is active and this power supply should work. And we have to check, if we don't find this voltage in the optocoupler, maybe we have some short circuit, some capacitor, some diode. Here are not too much components, just only this diode. We have some other components, capacitors, and here we have intelligent zener. We have this SMPS, this inverter section, to give 5 volt here. When we have this 5 volt, this voltage will apply to this green wire, and it is also applied through these transistors, set of these transistors, to this pulse width modulator PWM controller IC. So now I arrange the oscilloscope and I will connect ground to black pin because we have to connect the ground, signal ground. When you work on any equipment, see the data sheet of the IC. In this circuit we use AT2005. AT2005, go to datasheet, and when you will go to datasheet you will find something like this. Here are the pin out 1 2 3 4 5 8 9 10 11 like this, and here there is indication type. I means input, P means power, O means output. So we have this. In the first stage we have to check the VCC, pin number 15 and 7. Pin number 15 and 7. So pin number 7, that is ground. We have to connect the ground, and we have check pin number 15. This is standby voltage. This standby voltage are applied to this IC. Okay. If we have TL494, 594, we will find voltage at pin number 9, 10, 11, 12. Pin number 12, that is VCC. If we see from this standby voltage, we have one line here, and this is going to pin number 12. So we have to check pin number 12 and 9. So in this 2005 IC, in the first troubleshooting procedure, you have to check the VCC pin number. This is basic test of any circuit. When you want to work on any circuit, you have to check the VCC. When we have VCC, then our circuit can start. Now, in the case of TL294, we have this green signal, green wire through this Q10 transistor, Q1 transistor. This is connected to pin number 13. 13 is control pin. The pin number 13, that is control pin. And in this IC, we have control pin at pin number 11, remote on off. We applied VCC at pin number 15, but this IC will not work. Why? It needs a control voltage like a circuit breaker, like a remote. I will connect to pin number 11. Pin number 11 auto set. So we have 5 volts, and now I will connect the green to the ground. We can see now it is 0. Now it's 0. Okay. Same time I will connect multimeter. We can see I connected here. I get 5 volt, and I have no power in the secondary power. Now I will connect the jumper to green and black, and we have output in the multimeter. See, in the multimeter we have output. Okay, when this jumper is removed, this IC have output at pin number 9 and 10. Pin number 9, 10 are output. We will monitor pin number 9 and 10. 9 have no voltage, 10 have no voltage. Now I will connect pin number 9 and I will connect jumper. So this IC started pulse width modulation. So we have a switching frequency at pin number 9 and pin number 10 of this IC. Okay, now we can say this IC is intelligent monitor. We have output in the multimeter. I have output. The same time, if any power supply will get short, the IC will stop functioning. The multimeter is stopped. The jumper is installed. So I will remove jumper again. Anytime in normal condition, this SMPS controller have no output. But when we will connect pin green and black, it will start to giving pulses, and these pulses will transfer to these two transistors 1 and 2, and these will drive this small signal transformer, this small transformer beside this, and this signal will be rectified in half wave rectifier and applied to these two FETs, MOSFETs, and these MOSFETs will switch these 330 volt one by one to this chopper, PFC transformer. PFC, after PFC we will take different outputs, and we have rectifiers, and these rectifiers will rectify the voltage, and we will get these voltage from these filters and capacitors, everything. And at the same time, all outputs are applied again to this IC, and this IC will take 3.3 for monitoring, 5 volt, 12 volt, and total power, and it will check everything. If any power supply have short circuit, it will cut the output immediately. Even the remote command is available, but it will stop functioning. If any power supply, we will make a jumper, we will make short circuit between different power supplies, and we will check the response of this IC. We can see pin number. Now I have output of the PFC. Now I will make jumper between any power supply. Output is disabled. I will remote on again. It will start pulsing. Now I will make jumper between 5 volt power supply. If any power supply have short circuit, it will take a full drive, after that turn off. Now I will make jumper again. SMPS is driving the power stage, and I will turn short between 12 volt. It's off, no voltage. We can say this power supply monitor is very intelligent. So now I will make jumper between 12 volt and ground. It is in full load condition. That means for protection the jumper is installed, but the IC will in off state. So in this condition, if we have this situation, the power supply starts and then it goes in off condition, we have to check the output voltage. Maybe any one voltage is missing, or if any supply is missing, in that condition we will not find switching here. We have to Sometime we turn on power. After turning on, it goes off again. It is our very common fault. We turn on the power, after that it goes off. So we have to troubleshoot the voltage here. And if we have this chart, data sheet of the IC, we will check pin number 3. 1, 2, 3, 3.4 volt, that's okay. Then we have to check pin number 4, that is 5 volt. Then pin number 5. These are the voltage from different power supplies. If every power supply is available, 1, 2, 3, 4, 5, if these supplies are available, so that time we can say it will allow to make pulse width modulation at pin number 9 and 10. Pin number 9 and 10, because it is half bridge technology, so it will allow for switching in the both FETs, MOSFETs. Any diode, rectifier here, any capacitor here is short internally or externally. If any wire is short, it will make disable signal. This IC, if any power at this pin will go out of limit, this IC will turn off the signal. Some power supplies have different voltage regulator protection circuit like this. It have +5, -5, +12, -12, +5, 3.3. So this circuit is also working in as the same this IC. This IC have double function, pulse width modulator plus over voltage protector. If we are using TL494, 594, that time this pin, 13 number pin, is also controlled by over voltage and the command signal. Same here, command signal is applied to pin number 11 and over voltage pin 345. Any problem in voltage or any problem in command, this will disable the output. So we have to troubleshoot. If we have problem like this, our power supply turns on and then goes off, so we have to check these parameters. Anytime we have any short, anywhere we have short, our system will not work. In the first step, we have to check standby voltage, then we have to check the power on, PS on command, that's 5 volt. Then we will jumper 5 volt with any black wire to turn on at local mode, this or this. So in that case our power supply should start, and we will, when we make, if we monitor with multimeter, I will connect to pin number 11. I am taking 4.9 volt. When I take 4.9 volt, I have to connect this jumper. It will go to 0 volt. When it is 0 volt, that means power supply should work. Now I will check the output power. This time 3.5, 5 volt. So I have output powers. So in this condition, we have to monitor the pin number 11. If pin number 11 have voltage 0 volt, the same here TL594 at pin number 13. Here is pin number 13, here is pin number 11. If we use a circuit with the 2003, this 2005 IC, if we have 2003 IC, that time our PS on command will pin number 2. Here is pin number 11, here pin number 2 in this IC. So just go to datasheet, read the number from the chip IC and check the pin out, check the datasheet. Where is the command signal? If this power supply does not power on, check the command signal, and then very easily you can troubleshoot the circuit. I think this video is good for you. If it is good, you can subscribe, like, and if you think this is some useful, you can share with your friends if you want. Maybe someone can take benefit. And if you did not subscribe yet, make subscribe for my channel. And if you want to watch my future videos, press the bell icon button. And what is the quality of my video? And if you have any question about my video, let me know in the comment box. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.